All right. Good afternoon once again. Good afternoon, everyone. Um, you're all welcome back to today's class. We started it last week Saturday, but we were unable to conclude it because of some technical issues. But by the grace of God, we'll be able to start and finish our class today. So, my name once again is Samson Adeniyi, and our topic for today is binary code. Is that okay? So we started it since last week Saturday, and we got halfway through the class, but we we're able to finish. But today we're going to run through everything. So the next slide, please. So what is binary code? Binary code is the most basic form of computer code consisting of two numbers, 0 and 1. These numbers form the basic layer of all computing systems. All computing systems include our phones, all our gadgets, every electronic device that we have. Yes, those are all computing systems. So these numbers form the basic layer of all computing system and are the primary language of digital technologies. Binary code uses combination of these two numbers, which is 0 and 1, to represent numbers, letters, and other types of information. So the way we speak English, our system cannot understand English. So it has to convert it into something that is able to understand and work with, which is zeros and ones. So if I say my name now is Samson Adeniyi, it has to convert that letter by letter. Each letter has its own binary code. So the computer will convert it to a language that it can understand. Is that okay? Um, the next slide, please. Next. Okay. This is how it works actually. This is a computer system, and I'm sure we've all learned the part of computer before in our previous classes. So um, what we have on our screen now is a monitor, a keyboard, a mouse, and a CPU. So if you want to input an information into the computer system, you will use your keyboard to type the letters on it. Then the keyboard transfer those information into the CPU where the interpreter is. That's where the interpreter will now break down each letter into the numerical codes that the computer will understand, into the binary code that the computer will understand. So you type into your keyboard first, it goes into the CPU, then there's a processor in the CPU. Also, our phones have their processor. Every electronic device has its own processor. So it goes into the processor and changes those words, those letters, those numbers into binary codes for the computer to be able to understand, and to display it on your screen for you in a way that you also will be able to understand. So, next slide, please. So, here are the binary alphabet. So, the way we have our own alphabets that we used to um, um, communicate. The most universal language in the world is English. So, we have 26 letters in the English alphabet. Okay. So we have 26 letters in the English alphabet. So each of those letters have their own binary code. Is that okay? Starting from A, so starting from A to Z, there's a binary code for that. Starting from A to Z. So as you can see on your screen, the binary code for A is 01000001. So if you input A on your keyboard, the keyboard sends it into the CPU where the interpreter is. The interpreter will now convert it into the binary code. Is that okay? So each alphabet has its own binary code. Is that okay? So here they are on your screen, from A to Z. Is that okay? So please let's move on to the next slide. All right. Here are the rules of writing in binary. Is that okay? So also there are some rules, just like we have in English language. There are some rules that you must follow to be able to write in English language. I cannot want to say my name is Samson in English, then I will now say his name Samson. That is totally wrong. So there are some rules that must be followed when you want to write in binary. Is that okay? So the first rule is to represent space. So the first rule is to represent space in binary. Space is represented by 001, 00000. So two zeros at first, then one, then five zeros follows it to represent space. Is that okay? So to represent capital letters. So if I want to say my name now and I want the M to be in capital letter, for me to write it in binary code, I want to start with 010. Is that okay? So the capital letter starts with 010. Is that okay? So the lowercase letters start with 011. Is that okay? So these are the rules. Space starts with two zeros, a single one, and five zeros after. Capital letters start with 00. Is that okay? And lowercase letters start with 011. Is that okay? So these are the simple rules. So in case in case you want to like read in binary, probably your computer displays some numbers on its screen and you want to interpret English language, these are the things that you should take note of. All right. So the next slide, please. So this is an example of me trying to convert my name to binary. Like I said from the beginning. So like I said from the beginning, my name is Samson. So I want to convert it to binary. So as you can see, the spelling of my name is Samson. Is that okay? Samson. So if I were to type that into a computer system, it will convert it into binary code. So what it will do is, if I type the S capital letter, it will start with 010. If you can remember, the rule says 010 represent capital. Is that okay? So 010100011. That is the capital form of S. Is that okay? That is the capital form of S. So the second letter is A. It's a lowercase letter, so it's going to start with 011. Is that okay? 011. So lowercase 0110001. So that's lowercase of A. Is that okay? So we have done capital S and lower A. So next is M. 0110101. That is to represent M. That is to represent M. So the next letter also is S. Please pardon what you're seeing on the slide. It's supposed to be a small letter S. So and small letters start with 011. Okay. Small letters start with 011. So small letter S is 011001. Is that okay? So then O. O is small letter O is 0110111. Is that okay? And for letter N, 011011110. That is for letter N. So this is basically my name in binary. Is that okay? So you can also try to to interpret your name also in binary using the previous the previous letters that I showed you in the slide, how to convert each letter to binary. You can also try to convert your own names to binary. So next slide, please. Also, we can convert numbers so into binary. Like I said, we can convert letters and now we can convert numbers. So in binary, 1 is just 1. Is that okay? 1 is 1 in binary. And 2 in binary is 1. 2 in binary is 1 0. And 3 in binary is 1 1. 3 in binary is 1 1. So 4 in binary is 1 0 0. 4 in binary is 1 0 0. 5 in binary is 1 0 1. 1 0 1. 6 in binary is 1 1 0. 6 in binary is 1 1 0. 7 in binary is 1 1 1. 7 in binary is 1 1 1. Also, 8 in binary is 1 0 0 0. Is that okay? 1 0 0 0. Also, 9 in binary is 1 0 0 1. 1 in binary is 1 0 0 1. Also, 10 in binary is 1 0 1 0. 10 in binary is 1 0 1 0. So I will show you how to convert some other numbers now, because there is a trick, or it's not a trick, there's a mathematical process in converting other numbers to binary. Is that okay? So I will share my screen with you now so that you can see how to do that. So let's say um so let's say I want to convert the number 20 to binary now. I hope you all can see this number 20 to binary. So what I need to do is I need to break 20 down by dividing it by 2. Is that okay? I will divide it by 2. So 2 divided by 20 will be 10, remaining 0. So that's why I said 10R0. The R means remainder. 10 remainder 0. Also, I'll divide the 10 by 2. That will be 5 remaining 0. Okay. 2 dividing 5 now will be 2 remaining 1. Now 2 dividing 2 will be 1 remaining 0. Is that okay? So now 2 divided by 1, which is impossible. 2 cannot divide 1. So that will be 0 remaining 1. So that one could not be divided. So that's 0 remaining 1. So then you can see this arrow going up, meaning all the remainders here, we'll pick them one after the other from the bottom to the top. That will be 1 0 1 0 0. So 20 in binary is 1 0 1 0 0. Is that okay? So this is basically how to convert any number to binary. Just keep on breaking it down by 2, divide it by 2, divide it by 2 until you get to where you can no longer divide again. Is that okay? Then you count them, then you pick the remainders from the bottom to the top, and that will be your binary code for that particular number. Is that okay? So um that will be the end of our class for today. So we've learned how to convert letters into binary, and also how to convert numbers into binary. Is that okay? These are letters to binary now from A to Z. That's letters converting into binary. Also, we have rules to converting letters into binary. The rules for your space, you have 0 0, 1000000. That is to represent space in binary. Then for capital, if I want to write a capital letter now, I need to start the binary code with 010. Lowercase, I need to start with 011. Is that okay? And we also have how to convert numbers into binary. So this is numbers into binary now. So I hope we understood what we've learned today, and I hope that we'll put it into practice. It's not hard at all to convert letters and numbers into binary. You can on your own try to convert your name or some sentences, in fact, into binary. So thank you everyone for watching, and also don't forget to subscribe to our YouTube channel. Thank you very much.